Awesome. Okay, this is our last booklet, last unit that we're gonna do, and then we're completely done our course. So the last booklet or chapter is on probability, and some of the stuff that we know already are probably in this booklet. Okay, I'm pretty sure some people have heard of the word probability before, so a lot of things are not super new. So let's just get started. So probability is a part of mathematics called statistics. So this is where they gather data. Okay, that's what statistics is. And gotta put on my microphone. So probability refers to the chance. So you can replace the word probability with the word chance. So the probability refers to the chance that an event will happen. So event, some kind of situation, will happen. For example, when the weather person states there is a 30% chance of precipitation, okay, 30% chance of snow, 30% chance of rain, this means that there is a 30% chance that it may rain or snow, but we don't know for sure. Okay, so we don't know for sure. If a favorite sports team has 80% chance of winning, okay, so a higher chance of winning, then it looks like it's very likely that they will win, right? You just started. You're welcome. So let's examine like two of these examples. So on Monday, statement one, the probability of rain on Monday is 20%. So that's pretty low, right? Pretty low chance that it's going to rain. Statement number two, the probability that it will rain on Tuesday is 90%. So will it rain on Monday? There's a small chance, but there is still a chance, right? So maybe not, right? We're not sure. Will it rain on Tuesday? There's a higher chance, but there could also be a chance that it won't rain. Will it rain on both days? We don't know. Maybe, because these are the chances. So will it rain on either day? So will it rain on Monday? Likely not, right? Not, because it's a low percentage. Will it rain on Tuesday? Would say most likely. Most likely, because it's a higher chance that it will. It says it's 90%. Will it rain on both days? Now, we don't know. Okay, that one would be maybe. We're not sure, or probably. Will it rain on either day? Yeah, we don't know. So maybe or probably. So there might be a chance that it will, or there's a chance that it won't. That one we're not sure. Okay. So the probability is often expressed as a percent. So a lot of the probability that we see, and in reference to probability is in percent, right? In chance of snow. Right. So when we look at the weather, most of that is percent. But they could also be expressed as a fraction, a decimal, or in words. Okay. So the first example is already done for us. Okay. So as a fraction, 6/10. 6/10. To change it into decimal, how do you change this fraction to a decimal? Do you know? So you go, if you have the fraction, how would you change a fraction to a decimal? Divide, right? Yeah, you're gonna go 6 divided by 10. 6 divided by 10, we're gonna get 0.6. I'll just put that onto the screen. So 6 So 6 divided by 10. So from fraction, we can change the fraction to decimal, so 0.6. And because we want to write it as a 2 decimal places, that's why they added an extra 0 there, right? So 6 out of 10. Now that you have it in decimal, how would you change it into percent? Yeah, times it by 100. Okay, so times it by 100. So 60%. And then you can write it in words. You can say 6 out of the 10, the chance that something is going to happen. Okay. Now, what we're going to do is, if we have percent, how can we write the percent into words, into decimal, or into fractions? So let's start with this one. It's 19%. How can we write that as a fraction? Can we write that as a fraction? Can you see the word per cent? Per means divide, cent means 100. So the word percent means divided by 100. So when we go 19%, that means 19 per is divided by cent 100. Okay. 19% means 19 out of 100, or divide by 100. How can we write that as a decimal? So 19 divided by 100. 19 divided by 100. It's going to give us a 0.19. And then writing it in words, we can say 19. I'll just go like this. 19 out of 100. Okay. Is that good? Okay. Now, something is stated in the words. Can we write it as a fraction, decimal, and percent? So it's 35 out of 50. So 35 out of 50, you can write it as a fraction. So 35 out of, or divided by 50, or over 50. How can we write it as a decimal? We can go 35 divided by 50. 35 divided by 50. It's going to be 0.7. 0.7. But on the exam, they would ask us to write it in 2 decimal places, so we put an extra 0 at the end to make it 2 decimal places. Okay. And how do we write that as a percent? So now it's a decimal, changing it to percent, times it by 100. So 70%. Is that okay? So for a second. Now wait, about this one, 0.54. Now what we could do is to change it into percent first. So we multiply by 100. So 0.54 times 100 to change it into percent. So 54%. Now that it's in percent, we can go back to fraction. Okay, the word 54% means 54 divided by, or out of, 100. And then finally writing it as the words. So 54 out of 100. You have to write it in words? Yeah. Well, we could write it in words, yeah. On the test? Yeah, you could, or you can just write it like that. Yeah. Okay, so first, is everybody okay? Very quiet? Yeah. 1/8, so writing it into decimal, we have to go 1 divided by 8. 0.125. And if we round it off to 2 decimal places, it's going to be 0.13. Because it would just round off the 2 to 3, round it up. And then, oh, this is percent. Okay. So leave it out like that. Times 100. So it's 12.5. Okay, now this is going to be 1 decimal place, so 1.50%. And then last but not least is going to be 1 out of 8. Okay. Is that good? So most of the time, the chances, we hear probably as percent, maybe in words, maybe in fraction. So on page 2, it says here, in a science textbook, 23 out of 57 pages contain a picture. Express the probability in the form of fraction, decimal, and a percent that are randomly selected will contain a picture. So what is the chance? What is the chance that we're gonna, when we open up a book, it will have a picture?
You
booklet. I'll catch you up in a second. Okay.
My boss didn't even show up.
Oh. Especially today, because extra snow. Yes, yeah. Here, you can have this one. Good one. Hello. Thank you. We're just on page 2. There you go. We're just on page 2. Okay, where are we at? So you open up a textbook, randomly selected page. What's the chance that there's gonna be a picture on that page? So 23. So the way they had it here is in words. So what would that be in a fraction? So it would be 23 out of, so divide by 57. So 23 divided by 57. We can write our probability as a fraction. Writing it into decimal. So I'm just going to go over here. So from fraction to decimal, you're going to go 23 divided by 57. So we'd have to use a calculator for that one. So 23 divided by 57 would be 2 decimal places. 0. We said it in your booklet. 0.40. Yeah, it's 2 decimal places. We're on page 2. Okay. So from fraction to decimal, rounding it off to 2 decimal places. And now that we are on the decimal, we're going to change it into percent. So from here, we're going to go multiply, so times 100 to make it 100%. So times it by 100, so times, I'm going to keep all of my decimals there, and times it by 100. Now from here in percent, I still have to carry on with the 2 decimal places. So it's going to be 40.35%. Okay, so don't round off until like the very end. Okay, is that good? Is that okay? So fractions to decimal. Yeah, that's a new booklet. We're starting the last booklet. Or last. Yeah. Oh, I'll catch you up in a second. Okay, yeah, because I have to give you some assignments. Yeah. Okay, is that good? Any questions? So the probability, when we say the probability of 100%, it means a certain event. It means it will happen. It will happen. Okay? So here's an example for that. If today is Sunday, then the probability that tomorrow is a Monday is 100%. Yeah, because that's a highly likely or certain event that it will happen. And the next one is an impossible event. So an impossible event would be a 0% chance, right? 0% chance. So for example, for today, if today is Wednesday, then the probability that tomorrow is Friday is 0, right? So that's an impossible event. Okay, so 100% is for sure that it will happen, and impossible event, it will never happen, so the percent would be 0% chance of happening. And this one's complement. We need this for later on too. Complement. Well, what does a complement mean? So complement in statistics, in probability, means the opposite. Okay, so I'll refer to that in a second. A complement refers to the quantity of amount that completes something. So you can think of the part needed to complete a whole. For example, if there's a 20% chance that it will rain today, so it's a 20% chance it will rain, then there's going to be 80% chance that it will not rain. So there's like a picture for that, right? So the whole thing is 100%. 20% will rain, and then the complement would be 80% that it will not rain. Okay, so they're complements of each other. Let's take a look. It says here 15%. 15% chance, let's say, that it will rain. What's the complement for that one? 85. So we can say 100% minus 15%. That's 85%. So the complement is 85%. What would this be? 4 sevenths. Okay. Now 4 sevenths. Well, what's the whole thing? It's the whole thing. the whole thing would be 7 sevenths, right? 7 sevenths. When we talk about fraction, 7 sevenths is the whole thing, right? And if we subtract the 4 sevenths, that's going to give us 3 sevenths. Is that good? Is that okay? What about 32 divided by 50, or 32 out of 50? What's the whole thing? The whole thing, to make it as a complete whole, would be 50 out of 50. So 50 out of 50 minus 32 out of 50. Okay, that's going to give us 18 out of 50.
So that one would be 1.00843.
Oh, are you already thinking about the next one? Yeah, that's right. So in this case, 0.3, the whole thing would be 1. So 1 minus 0.30. It's going to be 0.70, because this is the whole 1. Next one, 0.47. So your probability is 0.47. What's a complement? It's going to be 1 minus 0.47. So that's going to give us 0.53. And last but not the least, now this is percent. So the whole thing, the complete, would be 100%. So 100% minus 89%. That's now 11%. So the percents would add up to 100. The fraction will add up to a 1, and then the decimals would also add up to a 1, right? So 0.3 and a 0.7 will be 1, 0.47 and 0.53 will be 1. Are there any questions about that? We're going to revisit the complement later when we get into the odds.
Can you roll down
A bit? This way?
one more?
More?
One more.
One more? More?
Yeah.
Okay. So we're gonna see the next page right away. Hmm?
So you just wrote it like that, you don't up, right?
Yeah, because when we look at this one here, and that's just the rule for the provincial exam. When we write our provincial exam, it's going to be always 2 decimal places, no matter what. So when we divide this, it's going to give us 23 divided by 57. Yeah, 0.4035. We round it off to 2 decimal places. That's why we only wrote down 0.40. Okay, and then we don't round off here yet to go to the percent. So times it by 100. Oh, I think I times it by 100 too many times. So 23 divided by 57 times it by 100. 40 point, And then 2 decimal places would be the 3-5. So we have to put the 3-5 there for writing our answers in 2 decimal places. And an example on a provincial exam. Not this one. I think we'll have to take a look at the next lessons. Okay. Let's get into experimental and theoretical. Okay. Is there anybody here who's maybe have like a quarter that I could borrow?
I do.
Okay. It's just to show some kind of like. Yeah. Thank you. I'll give it back. Okay, so let's say with this one, I like to maybe show this to everybody. Experimental and theoretical, okay? So you know that you're familiar with this. This is a head, and then the flip side would be the tail, right? If I ask you this, what is the chance that I'm gonna get a head?
50-50.
The chance that I'm gonna get a head, the head or landing like that is a 50% chance, right? Because that's, you only have a head or a tail, right? Now that's in theory, that's what we should get. Now here's what we're gonna do. We're gonna do a little activity here. Head, tail.
Take tallies.
We're gonna make a tally marks, okay? I'm only gonna do this 10 times, okay? I'm gonna flip it 10 times. Flip coin 10 times. Okay? I'm gonna flip it 10 times, and because I'm flipping this 10 times, I'm actually doing an experiment. An experiment that when somebody's doing an experiment, there's some data involved, right? You gather data, just like in science. So I'm gonna flip it 10 times. Oops, there you go. Okay, so that's a head. Okay, you see that? 1. Tail. Head. Tail. Ooh, it's a tie. Maybe it is 50-50. Tail. Whoa. Tail. Okay, tail. How many do I have now? 6. Got 4 more. Tail. Ooh, tail's winning. 3 more. Head. Tail. Yeah, that's tail. How many do I have? 5, 6, 9. So 1 more. Tail. It's tail. Oh. Thank you. So that one, because we actually went through the process, went through the experiment, gathering data, this is called the experimental probability. Like going through the process of gathering data. Earlier, we said the chance that we're gonna get ahead is 50%, or 1 out of the 2 chances, in theory. But experimentally, the chance was that we got a tail. Probability tail, oh, sorry, I said head. Through the experiment, we got a head, 3 out of, how many times did I do this? 10 times. 3 out of 10 times. So that's 30%. Instead of 50%, it's only 30%. And I'm just going to show that to you how I got 30. So 3 divided by 10. So I've got 0.3 times it by 100. So that's 30%. Can you see that in theory it should be 50%, but in reality, in experimental, it's 30. So when discussing a probability, it is important to know whether or not we are discussing experimental probability or theoretical probability. So experimental probability refers to the probability that is based on the past events to predict future probability. Past events can help us extrapolate information about what might happen in the future. Okay, for example, weather people uses previous weather data to predict what the weather will be like tomorrow, next week, or even next month. Okay? Theoretical probability, on the other hand, is using the possible outcomes to predict the future probability. So this does not need any past events to calculate the theory. So experimental probability is what, based on what happened okay, so the experimental probability is based on what happened, and theoretical probability is based on what should happen.
Excuse me.
Mm-hmm.
I have a question. How did you get 30%?
How do I get this 30%?
Yeah.
Because the head, like when I flip the coin, I got it 3 times.
Okay.
Yeah, so when I flipped the coin, I got head 3 times. 3 out of 10 times that I tossed it. I flipped it 10 times, so 3 out of the 10. So 3 divided by 10. I'll do that. 3 divided by 10. I'm gonna get 0.3.
Yeah,
And then changing it to percent, so timesing that by 100. So 30%.
oh,
Okay? Okay. So let's take a look at example number 4. It says, Amika has six-sided cube, and each face is labeled numbers 1, 2, 3, 4, 5, 6. She tossed the cube 8 times, and then this is what she got. So this is the result from her experiment, right? She actually went through the process of tossing that thing around, and that's what she got. State the experimental probability of tossing a cube and showing a 6. So probability of showing 6. I'm just gonna write that down. So P means probability, and then I'm writing down what event am I looking at. Showing 6 is equals to, okay, now I gotta go back here. How many times did she get the 6? There's 1, 2, 3, 4. Yeah, 4. Out of how many times did she toss the coin, or the cube? 8. So 4 out of 8. So 4 divided by 8 would be 0.5 or 50%. Okay. So based on her experiment, the chance that she's gonna get a 6 is 50%, half a chance. Now we're gonna take a look at the theoretical. What should have happened? What should happen? So 1, 2, 3, 4, 5, 6. So how many 6s does it have on this 6-sided cube? 1. So probability of showing 6, it's only 1. There's only 1 6 in that cube. Out of how many are there altogether? There's 6 of them, right? 1 out of the 6. So 1 divided by 6, 0.17. And if you round it off to writing it in percent, it would be 16.67%. Okay. Is that okay? Take a look at example 5. So there are 4 red marbles, 3 blues, and 2 yellows, and 1 green. So Marcel chooses a marble out of the bag and then replaces it back each time. He does this 5 times. He chose the following colors. So this is what she did. This is what her experiments shows. The result. Okay, so what is the probability? Express the probability of choosing the green marble. Okay, so probability of green. What's the chance that she got a green? There's 1, 2 greens. Out of how many times did this happen? So 1, 2, 3, 4, 5. 2 out of 5. Okay, so the chance that it's green is 2 out of the 5. She got green 2 times out of the 5 times she drew something in the bag. Okay. So 3 blue, yellow, 1 green. Oh wow, that's very, for some reason, oops, I said green. There's only 1 green in the bag, but really, when she kept drawing it from the bag, she's taking 1 marble from the bag. The first time she got a green, puts it back. The second time she got a blue, puts it back. Then she got a yellow, puts it back. Green again, puts it back. Yellow, puts it back. So it's 2 out of the 5 times that she tried it. What should have happened? What should be the chance of getting a green? Well, if this is a chance, like, is it a big chance that you're gonna get a green? No, it's not a big chance. There's only 1 green in this whole bag. So in theory, it should be the chance that it's green is 1 out of how many are in the bag? 1, 2, 3, 4, 5, 6. 6. Oh my goodness, I forgot the gosh, sorry. I started reading this. Is that what other people are wondering about too? 4 reds. I gotta put the reds. 1, 2, 3, 4. Sorry about that. Let's do. Okay. Repeat it again. Okay. There are 4 reds, 3 blue, 2 yellow. Okay. Back up the bus. Okay, what's the chance, experimental chance of getting a green? Okay, oh, this one is okay. So 2 out of the 5. So that one's okay. Now, in theory, how many greens are there? There's only 1 green out of how many are in the bag? 10. Thank you. There you go. It's 1/10. Okay. So is that better? I think that's better. Oh, let's see. Oh, last example. I think we could make it. Sorry it took a long time. Okay. It is important to note that for a large number of trials in an experiment, the experimental probability will begin to approach theoretical probability. Okay, remember the tossing of coin? If I do that like 1,000 times, the theoretical probability will get closer and closer to the theoretical probability, right? Because I only did it 10 times. So, but if I do it 1,000 times, it's going to be 50%, almost 50-50. So Bindi tosses a coin 10 times. She records her finding 9 heads and 1 tail. Okay. State the experimental probability of tossing and landing on heads. So probability that it's landing on heads. Okay. So she got heads. How many heads did she get? 9. How many times did she toss altogether? 10. So 9 out of the 10. And state the theoretical probability. It's going to be either head or tail, right? Those are the only 2 choices. So probability of head is going to be 1 out of the two possibilities. So a half. Okay. And what would happen if Bindi tossed it 20 times, 100 times? Experimental probability will get closer to theoretical probability. There you go. Great, we finished.